Happy Math. It is Ms. Kosh. Let us do a few probability problems that require permutations and combinations. So this is the follow-up to what we did with the counting principle. So if you think about it, probability is just going to be the number of total events, the number of events that satisfy a situation divided by the number of total events possible. Okay, and so that often we'll use combination and permutations because what you're doing is you're counting how many ways certain things can happen. Let's jump in and look at some problems and see if we can make sense of this. Okay, it says a combination lock uses 3 numbers between and possibly including the numbers 1 and 60. Find the probability that the combination does not repeat numbers. Okay, so what happens here, the funny thing is a combination lock is actually, it's not a combination for the code on it, it's a permutation. Because if you think about it, do you remember how like the combination lock, it looks something like this and you like spin the dial this way and then you have to go, I don't remember, anyway, you have to go all the way around and then go back to the number that you want and then you go this way again. Okay, that was ridiculous. But the order matters, so they should call it a permutation lock. So if y'all would get on that for me and get the world to change, we can call those permutation locks instead of combination. Oh, okay, not funny. All right, I'll stick to my day job. You are my day job, but anyway. Okay, I'm done. I promise. Okay, so what they're saying here is we're trying to find the probability that the combination does not repeat numbers. So what can happen is in your lock, you've got 3 possible numbers. And if we have no restrictions, you've got 60 choices for the first number, 60 choices for the second number, and 60 choices for the third number. It can be 1 through 60, including 1 and including 60. So the denominator, when you look at the probability, is 60 to the third power. Okay, but they're saying, no, you don't get to just pick random numbers. You have to have 3 different numbers, and the number, let's see. So we want to see how many ways we can choose 3 numbers, but the order does matter because the order that you pick these things, if I have a combination of, 30, 60, 90, no, haha, I'm back to right triangles, 30, 60, 45, okay. It's not the same combination as 45, 30, 60, like those are not the same, that's not the same code on your lock. Okay, so we have to do a permutation, so we're going to do 60 permutation 3, and I am not able to really show you the calculator, but if you remember, you can go under option and then over to probability and then find, it looks something like NPR, and then it's right next to the button that has N, that's not an N, NCR. So the permutation would be was the first one I wrote, and the combination is the second. But luckily, I have this already worked from last year, and this becomes 205,320, and then divided by 216,000. And so you could reduce that to 711 over 1800, which is about 0.951. Okay. I'm relying on previous work I did, so hopefully those numbers are correct. I know I'm quite confident that this is correct, and hopefully the rest of it follows. Okay, so far so good. Let's look at the next one. Okay, it says we're making a committee of 6 students, and we have 14 SL students and 11 HL students. That was 2 years ago for me. Anyway, I had 11 HL students, and 1 was a girl, and the other 10 were boys. It was pretty fun. Okay, so it says, find the probability that both Sam and Christian are on the committee. In this regard, it doesn't really matter which class they're in, because we're saying we have one particular, like we need to get those 2, and then the other 4 we don't care. We have no other stipulations for those 4. So this one, when we're picking committee members, this is a combination. We don't care what order we get picked. We just want to be on the committee, or sometimes we want to avoid the committee. But anyway, join education and you'll see what I'm talking about. We have, as a denominator, we have a total of 25 students, and we want to choose 6 of those. And that's the total possible committees that could be formed. Well, now we've got Sam and Christian, and we need to pick both of those too. And then that means that the other 23 students, we need to pick 4 of those. So remember how we talked about that you can use the notation NCR can be written also as N over R. It looks like a vector or a matrix. It's not. Luckily, we don't mix contexts. But I mean, it's the same notation, but it means something different. Okay. So this 2 choose 2, there's just one way to do that, and you can plug that in your calculator. And then I'm relying again on work that I had previously done. This is 8,855. I didn't bring home a calculator over the summer. And then 25 choose 6 was 177,100. And so this reduces to 1 out of 20, which is equal to 0.5. I lied, 0.05. Did you catch that? Okay, good. Okay, so then it says find the probability that all 6 committee members come from SL. So once again, the total possible committees is 25 choose 6. And now out of those SL, we had 14 students. We want to choose 6. And then we could write this 11 students in the other committee, and we want to choose 0 of them. Excuse me. You don't really need that part, to be honest with you. I mean, sure you do, but 11 choose 0 is just 1. And so 14 choose 6 is 3,003 times 1 over, and then this is still 177,100. And so this becomes 39 out of, I assume I did this correctly before, but I don't have a calculator right now to make this easy for me. IB likes 3 sig figs. Oh, you know what? Probably it rounded to making that the sig fig. So we probably do need that 0 for IB. But I don't have a calculator to verify. So check and see if you agree with me. Okay, the last one says, find the probability that the committee has at least one member from both classes. Okay, so what we can think about is we have HL kids, we have SL kids. We could choose 0, 1, 2, 3, 4, 5, or 6 HL kids. And if we had 0 from HL, then that would mean all 6 would have to come, all 6 of the kids chosen on the committee would have to come from SL. And then it'll be 6, 5, 4, 3, 2, 1, 0. So basically the probability, we're looking for the probability that the committee has at least one member from both classes. That means we want these options here. Okay, so we could either find the probability of all of those, 1, 2, 3, 4, 5 things happening, or we could say it's 1 minus the probability of no HL plus the probability of no SL. Okay, or you could say no HL would also mean all SL. I think in my answer key I wrote it this way. I said 1 minus the probability of all SL plus the probability of all HL. Would you agree that those are equivalent? I hope you would do. Okay, so this is 1 minus, well, how do we get all SL? We have to do, we have 14 SL kids. We want to choose all 6, and then it's 11 choose 0. I might not even write that, but I did for you just then. And this is 25 over 6. And then the probability of getting all HL, the 14, you choose 0 of them, and the 11, you choose 6 of them. And then this is over 25 choose 6. That's totally wrong notation. Let's try that again. There we go. And so I wrote this down in my on my answer key from before. So then it becomes 1 minus, well, 14 choose 6. I think we've already seen that number. It's 3,003. We know that 11 choose 0 is 1. I'm not going to write that down. Oh, and you know what? We're going to have the same denominator that we have already seen. And then 11 choose 6, if I wrote this down correctly before, is 462. And then 14 choose 0 would still be 1, or would be 1, just like 11 choose 0. And so now it ends up, I wrote this down, I said it's 1 minus 3,465 over this 177,100, which is equal to 173,635 over 177,100, which reduces nicely well, luckily, that's kind of an annoying number. Not that this is a pretty number, but to 451 over 460, which is about 0.980. So the probability that you would pick a committee of 6 kids and that they would be in both, that you would have both classes represented is about 98%. So you've got a pretty good likelihood that that happens. Okay, I hope that was helpful using the first one we were using permutations, and the second one we used combinations. So go practice. Good luck to you.